Now we're going into our third question of the day. There are two of them that I wanted to cover. Guys, very important revision for your trig. Okay, so pay attention. We're going to go slowly. It's one of those reduce the long sentence to one ratio. So very important. Let's take a look. It says the first question we're going to do, simplify the sine of 180 degrees minus x multiplied by cos of negative x plus cos of 90 degrees plus x multiplied by cos of x minus 180 degrees to a single trigonometric ratio. Okay, guys, when you get single trigonometric ratio, even if you end up getting 2 minus 3 sine x, which hopefully you don't, this is not a ratio. That is fine. That is still a number. It is totally fine. We're just looking that you've reduced everything to be in terms of sine or cos or tan. Okay, so in this question, we need to break down each term really slowly. So sine of 180 degrees minus x. Let's draw a little cast diagram. We've got quadrant 1, 2, 3, and 4. Okay, and cast says that cos is positive in the fourth, all of them are positive in the first, sine is positive in the second, and tan is positive in the third. Okay, that comes from your ratios. You should know that. We started that in grade 10 even. So sine of 180 degrees minus x, guys, sits in this quadrant over here because this is 180 degrees, and if we're minusing x, we're going to about there. Okay, so always in the second quadrant. In the second quadrant, sine is positive. So sine of 180 minus x is the same as saying sine of x. Okay, that's the first term done. Cos of negative x. Okay, so let me get my cast diagram a bit bigger where you guys can see it nicely. Okay, so cast diagram, C, A, S, and T. Cos of negative x, if I start from the positive x-axis, which is where I have to, and I go negative theta, that is where negative x sits. And looky here, we are in the fourth quadrant, and that is where cos is positive. So we are multiplying by positive cos of x. Okay, second term done. So now, plus cos of 90 degrees plus x, okay, co-ratios, very, very important. Cos and sine, when they have a 90 attached to them, they swap to their co-ratio. So 90 degrees plus x is going to give me negative sine of x, which is very important, okay. That's that term taken care of. And then the last thing that we have to deal with is this cos of x minus 180 degrees. Okay, so what you need to contemplate, guys, if we look at our Cartesian plane, x is always an acute angle, so it will sit somewhere up until 90. So for argument's sake, I'm just going to say that, let's say this is x. Okay, always an acute angle in the first quadrant. If I take x and I subtract 180 degrees, you guys know that angles on a straight line are 180. So this angle minus 180 is always going to end up in the third quadrant, okay? No matter where your angle is, if I drew this angle being x, 180 is still going to land me up in this third quadrant, okay? So if I take an acute angle minus 180 degrees, I end up in the third quadrant, and only tan is positive in the third quadrant, which means that cos of x minus 180 is negative. Okay, so once you've established that, it becomes easy peasy, guys. Simplification. Remember, if there's a plus, you need to deal with the terms on either side of it. So we've got sine of x multiplied by cos of x plus a negative times a negative is a positive, so that stays the same, and then sine of x cos of x. Okay, so we have some like terms here. That gives us 2 sine x cos x. Okay, but guys, very important, single trigonometric ratio. You need to know that this is the identity for sine of a double angle. Okay, we don't want to see any cos in there. We want to see just one trigonometric ratio. So this is the identity. It appears on your formula sheet. Next part looks quite daunting, but is actually quite simple. It says determine the value of this whole expression, sine of 3x times cos of y plus cos of 3x times sine of y. Okay, on your formula sheet you will get something that looks like this. Sine of a plus b is equal to sine of a times cos of b plus cos of a times sine of b. Okay, it's up to you to recognize that if I have this angle there attached to the sine, and then the same angle attached to the cos, which I do here, sine of 3x and cos of 3x, and then I have the same angle attached to the cos and then to the sine, which I do here, that is a compound angle formula. Okay, so if you wanted to, you could say, let A represent 3x and B represent y. If you feel like it, it's going to help you out a little bit with your representation. That means that if I rewrite this, I have this expression right here because we got sine of 3x, which is A, cos of 3x, which is A, cos of y, which is b, and sine of y, which is b. So that means that that expression is equal to sine of 3x plus y, this whole expression here. Okay? Then they give it very adamantly that 3x plus y is 270 degrees. So we're going to get sine of 270 degrees. Okay, you guys should know from your graph, sine starts at 0, goes to 1, 0, negative 1, and then comes back. Okay, 0, 90 degrees, 180 degrees, 270. So you should know that sine of 270 is negative 1. Otherwise, you can always just go and check it out on your calculator and you will get negative 1. Okay, so guys, often you will learn this identity off by heart or how to use it, okay? But sometimes in a question, they will give you the split up expanded identity. They will say that I have sine of an angle times cos of another angle, etc. It is up to you to spot that that is the expanded form and you can reduce it back to just one trigonometric ratio of a double angle or compound angle. Okay, guys, sometimes you have to go backwards. Same as converse theorems in Euclidean. Sometimes you have to spot things and move backwards from them. Okay.